So the last video of week 8, we're going to talk about pressure volume loops. So we've got two outcomes or objectives for today, and one of which is partly review. So we've got preload and afterload and venous return, and I don't know why the animations are a little off there, but venous return is just the amount or the rate at which blood returns back to your heart. Preload is the pressure that's in your heart prior to contraction, and this is caused by end diastolic volume, right? So there's only two ways to increase pressure in a water balloon. You can either squeeze the water balloon or you can add more water to your water balloon. Well, the heart is the same way. And if we're in diastole, okay, or if this is the pressure before contraction, then the only thing that can cause pressure will be blood. And so more blood, more pressure, less blood, less pressure. And then afterload is just the pressure that the heart contracts against. Okay, so we have to open up that semilunar valve to get blood out of the ventricle and into the aorta. So aortic pressure is really what the afterload is when it comes to the heart. Okay, so now we've got pressure volume loops. And so with these pressure volume loops, I want to orient you here. So on the x-axis, we've got volume. On the y-axis, so here's my volume, and then we've got pressure. And then here we've got the four phases of the cardiac cycle. And it goes around and around. Okay, and based on what's going on with pressure and volume, you should be able to figure out what's going on or which phase you're in. So, and the phases go from basically at the corners here. So from there to there is A, B, C, and then back is D. So when we go from here to here, volume's changing, pressure's increasing a little bit. So if volume's increasing, really it can only be one thing, and that is filling. Okay, so when we go from here to here, volume's staying constant, but pressure's increasing, so it's isovolumic contraction. Here, pressure goes up, then it goes down, while volume goes down the entire time. That's ejection. And then finally, going from here to here, volume stays constant, but pressure goes down. That's isovolumic relaxation. The difference between the segments on the right side and the left side is our stroke volume. Okay, so we talked a minute ago and we've talked earlier about preload. What is preload? Well, preload is the amount of blood in the heart before contraction. So what's going to change with this loop? And really, is it the right side or the left side that's going to change? The answer is it's the right side. So if I increase preload, that means I'm going to have a greater volume. So we're going to go here. And so my heart's going to contract a little harder to get that blood out. But notice what happens to end systolic volume. So end diastolic volume increases, end systolic volume stays the same, but stroke volume increases. Okay, because we start with more blood and we get more blood out. So we have a greater stroke volume. Now, what happens if we decrease preload? It's similar, only instead of moving the far right to further right, we actually move this segment this way. Okay? And so what happens is end diastolic volume decreased, and systolic volume stays the same, and stroke volume decreases. Okay? So that's what happens with preload. Preload only affects end diastolic volume and stroke volume. Sorry, there we go. I'll circle them just to make it clear. So it only affects these two. It has no effect on end systolic volume. Now, what was afterload? Like I said a minute ago, afterload's that pressure the heart has to contract against, or in this case, it's aortic pressure right here. Okay, so when normally ejection time goes from when ventricular pressure exceeds aortic pressure, and then it ends when aortic pressure exceeds ventricular pressure. Okay, so really at these intersections right here and right here. All right, so what's going to happen? What's going to change if I increase afterload? And also, what's going to happen to ejection time? Well, the answer is, if I increase afterload, I'm essentially increasing aortic pressure, so we're going to shift that curve up. Okay, and so now, notice that the intersection's right about here and here, so ejection time is reduced. Now let's go back to our loop here, and I've only got one of these. I don't have a decreasing afterload, but you should be able to figure it out. So if I increase afterload, am I going to change the right side or the left side? Remember, afterload is the amount or the pressure that the heart has to contract against. And so what's going to happen is it's going to affect how much blood actually gets out of the heart. And so we're going to shift the left side of our curve to the right when I have high afterload. And so what happens to end diastolic, end systolic, and stroke volume? End diastolic volume stays the same. End systolic volume increases. There's more blood left in the heart. And this causes a decrease in stroke volume. Okay, so afterload only affects end systolic volume and stroke volume. Now, if I decreased afterload, that curve would shift out here, and it would look something like this. Okay, like that. Okay, so that's the end of week 2. Can you do the following 2 things? Can you draw a pressure volume loop, label the figure, and then label each phase or identify each phase of the cardiac cycle? And then can you describe what happens to that curve when we change afterload or preload?